Okay, well, thank you very much. And particularly to Tara and Bea, that's a really nice connection through to my focus today. So I'm Bill Austin. I'm based at the University of St Andrews. I also have links to SAMS, the Marine Lab on the West Coast. And I do have some connection to Scottish Government. I chair the Scottish Blue Carbon Forum. And so I really want to echo what both speakers have said about partnerships and the opportunities, I think, to connect eventually through to policies, but in that process, not to lose sight of all the stakeholders. And of course, as someone who's interested in the environment, particularly thinking about what we can do to help the environment. So it's appropriate, I think, to speak this evening to your group. I'm going to focus on an area of blue carbon where the frameworks articulate an opportunity for climate mitigation. So I'm going to focus on coastal habitats in this talk this evening. But I did want to just reflect a little bit on these offshore sedimentary organic carbon stores, because they intersect with some impacts which are increasingly spoken about by conservationists. And that's bottom contact gear and its potential to disturb the vast carbon stores in our shelf seas and contribute to those greenhouse gas emissions that Bea was talking about. So something we might add to that accounting process that Bea has introduced is, that impact on the natural environment. And of course, when we make those comparisons with agriculture, these are now factored in to agricultural practices quite routinely in the greenhouse gas emission accounting. And we're seeing radical changes in farming practices to reflect some of those changes. But the evidence, is still quite weak. And so to echo again Bea's point about policy that's evidence-based, I'm going to leave this till the very end and come back to it as something of a work in progress. So I'm going to focus on the frameworks where I can introduce ideas for blue carbon and highlight the climate mitigation opportunities. So this is a relatively new area. It's quite exciting. And, it's been supported by Scottish Government, and we're really making, I think, a lead across the UK in some of the work of the members of the forum here. The slide at the end I'll come back to, but it essentially shows some mapping of the carbon that's stored in these offshore sediments. And then on the right-hand side, it looks at one measure of fishing intensity. It's the swept area ratio of fishing bottom contact activity from bottom trawling. So you could start to put those two things together and think about potential impacts there. I borrowed this slide from Pete Smith, who's a colleague of Tara's at Aberdeen, and we worked together in the COP26 Universities Network on something called Nature-Based Solutions for Climate Change, People and Biodiversity. And this was a really nice report to work on with a group of colleagues. But the idea here, I think, is really encapsulated in this infographic. And what I'm going to highlight are that nature-based solutions through biodiversity in particular allow us to work with nature to create better outcomes. So sustainable development outcomes can flow if we work with nature. And I think increasingly this is being recognized, and it was great to see this move up the agenda at COP26 and to see the ocean climate nexus, if I can borrow the language from COP, move up that agenda. But some important points to make, I think, when we think about nature-based solutions are that, first of all, they're not alternatives to decarbonizing our economies. So we recognize, as Bea said, that we have to have these deep emission cuts. This is absolutely necessary. We cannot avoid this. We can't think of nature-based solutions as a get out of jail card. We also want in this process for nature-based solutions that they encompass protection and restoration, the sustainable management of a whole range of ecosystems, including the marine. And we need to design them with stakeholders in mind. So particularly in some parts of the world for and with local communities. And finally, increasingly, and I think Dasgupta's review of the economics of biodiversity last year, Royal Society report, really highlighted this point, that we need to address these measurable benefits for biodiversity. We have a biodiversity crisis alongside the climate crisis, and we need to work with nature to find good outcomes for both of these areas. And of course, the net zero agenda around blue carbon provides one of these opportunities. Okay, so I'm going to talk this evening just really briefly on one of these habitats that we've been working on. It's not directly linked to fisheries, but bear with me because it will illustrate the concept. And it is work that we've been leading at St Andrews, so it's helpful for me to talk about it. But it's about carbon storage in marine habitats and marine sediments. We know globally that 83% of the carbon cycle is involved with our oceans. So the oceans are extremely important player in the global carbon cycle and therefore the global climate cycle. These habitats, these blue carbon habitats, only cover a very small area of the ocean basins. And yet primary production of carbon in these places accounts for 50% of all marine sediments. So in terms of area for area, these are some of the most effective places on the planet to sequester and store carbon. So they're much better than the peatlands that you might well know in Aberdeen and other terrestrial habitats. So we've been doing some work to try and understand the stocks of these habitats. And the other key point here is that these habitats fall within the IPCC, the Intergovernmental Panel for Climate Change guidelines for greenhouse gas accounting. So the UNFCCC process that Bea described allows us to account for greenhouse gas emissions and sinks, of course, in these habitats, as we can now with our peatlands. So what we've been doing is working around Scotland, studying these habitats. They're very widely distributed. I'll take you through this fairly quickly. But in Scotland, we're particularly well placed to do the stock calculations for these habitats because our vegetation communities, these coastal wetlands, these salt marsh habitats have been mapped by NatureScot. And so we can use this to create an upscaled assessment for the total amount of carbon that these habitats store. And if we do that, when we look at the density of carbon stored in these habitats, and this is just the superficial layer, we see they're as good as virtually any other type of habitat that we would find in the terrestrial environment, so bogs and so on. But the additional point here, of course, is that the below ground store can be quite a considerable depth, much deeper than it would be in many terrestrial soils. So we're building up year on year, century over century, this long-term store of carbon in these habitats. So they're very good places for us to work with nature to try and hold on to that carbon sink, restore those carbon sinks, and avoid emissions from these carbon stores. The other thing is that we hear a lot about European exit and making some of these connections between the land and the sea. And these are really interesting places to start to think about new processes and incentives for agriculture that would influence the coastal environment and that would have benefits for nature recovery. And so we've done a little bit of work looking at sustainable farming incentives, local nature recovery, and then moving to a sort of higher tiered approach where we could actually look at whole landscape recoveries. So again, this is quite an interesting area. And the benefits here, of course, are changing practices that would enhance both biodiversity and carbon sequestration. And because these habitats sit at the interface to our coastal zone, they, of course, are very important potential nursery grounds. They supply nutrients, they clean up pollutants that are entering the sea. So, and they have all sorts of additional climate adaptation opportunities linked to them. For example, coastal flooding with rising sea level. So there are interesting places to think about changing management practices. Now, we've been doing a little bit of work, and we're due to report on this quite soon, but I thought this was an interesting example to show you, just to think about how these habitats, of course, might change as climate continues to change. Bea made the point that global climate is warming, and we heard last year from the IPCC in their Code Red for humanity, one of the key implications of rising global temperatures is that sea levels are rising, they're accelerating, and even if we reduce emissions because of some of the built-in consequences of a warmer world and ice melt, we're going to, and thermal expansion of the ocean, we're going to see sea levels continue to rise. So we've been doing some work to think about how these habitats might respond to sea level rise. And in this example, we've actually tried to project coastal realignment. So many of these sites around Scotland, around the UK, have been reclaimed from the sea. And this has been to create agricultural land, as you can see in this example. And here what we see is an opportunity to let the sea back in and actually restore some of these habitats. So this has been a really interesting thought process for us, because of course, if we can restore some of these habitats, we can create additional carbon sinks and climate mitigation opportunities, as well as the habitat gains. And so just looking at this example from near Dunbar on the east coast of Scotland here, the current area of the habitat is relatively small, but if we realign these coastlines through a process called managed realignment, we can get quite large gains in these habitats. And we know that will occur if we let the sea back in today. And in fact, some of these schemes show the habitats restored. For example, Skinflats, the RSPB site near Grangemouth, the habitats there were restored within 2 to 3 years and are now viable salt marshes and building up their carbon stores, and of course, creating new habitats, in that case, for migratory birds. And we can then think about how these systems would respond through time into the future. There's a lot of uncertainty here, of course, because we don't know the exact trajectory of climate change. But these RCPs, these are the concentration pathways of greenhouse gases which we could choose to emit or not to emit into the Earth's atmosphere. So RCP, the representative concentration pathway 2.6, is the best case scenario. This will keep us to the Paris Agreement and the 1.5 degree warming above the industrial or the pre-industrial baseline. And RCP 8.5 is the kind of worst case scenario, of course, in this example, driving very large amounts of sea level rise into the future. So lots of greenhouse gas emissions. And we can go through these very simple models to think about how this habitat would respond, with this projected sea level rise. And what's been interesting here is that, we see on the left-hand side of this diagram that we can create quite significant, at some sites, not all sites, of course, quite significant gains in habitat, gains in blue carbon potential. But over time, as sea level rises, if we don't see coastal realignment inland, which of course we could allow for more of that, then we start to lose these intertidal habitats. But it's actually, in this example, it's only in the worst case scenario of very high emissions that we end up with a smaller habitat area than we would have at the present day. And in nearly all scenarios, if we allow for managed realignment, we actually see an increase in the habitat at this particular site. So we could use this approach if we want to think about the area of habitat that we're trying to maintain, or even a target to increase the overall habitat area, and therefore, as I said, the blue carbon potential. This is quite an interesting approach. What I haven't said, of course, is the economic cost of creating managed realignment, and that's a whole other story. And of course, people are sometimes particularly worried about letting the sea back in. Culturally, we're conditioned to reclaiming land from the sea. Letting it back in is something else, and there are cost implications, of course, of doing this. So this is an interesting approach because increasingly there are investors who might buy the additional carbon credits that could be gained from such schemes, and that would help compensate some of the cost of creating the managed realignment in the first place. Okay, so this is an area that has attracted interest from government, partly because of the net zero agenda. And we've been doing work with Scottish Government really to, I think, build up the narrative, build up the political commitment. And we've recently done some work with the UK Climate Change Committee as well. And I'm very encouraged that the UK is moving towards the implementation of these habitats into our national greenhouse gas inventory. And we've seen that happen with our peatlands. And the peatlands, of course, are still emitting greenhouse gases, which isn't great, but we know from the science that if we restore and re-wet peatlands, they will become net sinks for greenhouse gases. And so we can go through this same process with these blue carbon habitats. And I think this will drive, great benefits and climate adaptation opportunities for blue carbon. And so the idea that I want to leave you with is that this is a construct. The idea that this habitat fits into the IPCC guidelines for greenhouse gas accounting is a construct. We understand the system and we say we can account for it. But why couldn't we think about our shelf seas in this same way? And so there is now a growing argument that in fact our shelf seas provide a climate service, and they are intimately involved, as is the whole planet, in our carbon cycle. So one of the challenges when we think about a diagram like this is that we might think immediately that the impact of bottom trawling would be disturbing these sediments. We know there's evidence about benthic impacts to marine ecosystems. That's very well documented over a long time from bottom trawling. What's not well understood at the moment is the potential for this activity, this pressure, if you like, to create a greenhouse gas emission. And so this is an area where the Forum and colleagues working with colleagues in Marine Scotland and Scottish Government are moving towards improving the evidence base. Now, there have been some papers. There was quite a well-publicized paper last year by Enrico Sala and colleagues published in Nature, where they made the argument that these activities globally were equivalent to the emissions from global aviation. Now, I think increasingly there's a consensus view in the science that this isn't quite right. And in fact, you know, I'm of that view, and I think there is evidence emerging now that will show that, you know, this isn't quite correct. But it does open up, I think, a really important dialogue about the future of fishing, particularly bottom trawling, and how we're going to manage our shelf seas. And in August last year, in a power sharing agreement with the Green Party, the SNP government made some new commitments to these highly protected marine areas, and blue carbon, so carbon in these habitats, in sediments, would become one of the criteria for the designation of these highly protected marine areas. So I think we're entering a very exciting space in which we're going to have to think very carefully about the evidence and about the process by which these highly protected marine areas are designated, as I say, to create the best outcomes for climate, for people, and for nature. So I'm going to end with this thought figure. It comes from Goldstein et al. It's a very interesting paper. It wasn't really written with marine habitats in mind, but and it's focused on terrestrial systems. But I think the challenge for us here with the science, with the policy that will flow from this, and I think for the greenhouse gas accounting that Bea was talking about, is to think about the impact, the potential through management to allow for recovery. That might be through restoration, it might be through protection, and how that recovery would play out in time to create, in the case of climate mitigation action, additional carbon, and the permanence of that carbon that we could demonstrate going forward over time. But as I say, and I'll end on this note, I think this is a really exciting intersect at the moment between the pressures that can come from fisheries and the way that we're rethinking the services of marine ecosystems. So thank you very much for the chance to speak this evening.